Hello to my friends, welcome to GT CAAD. Today we have the practice for the beginner Solidworks user. As you see, we have the shaft. I just did it in one feature. Okay, the main feature that I use is the revolve boss base. It doesn't need to use several times and use extrude boss base to create the various of the diameter in shaft. Also, I teach you how to create a plane on the cylindrical face, and here we have the drawing. You can download it, the PDF, also the solid parts in Telegram channel. The link is on the description. Also, you can take a screenshot. I can zoom out. You can take a screenshot of this drawing and model it step by step with my video tutorial. Back to the SolidWorks. Press and Ctrl N. Create a new part. In the sketch tab, create a sketch on the front plane. I minimize the windows, also the SolidWorks. Drag it the PDF to right Windows side and select the SolidWorks windows. It should be the next to SolidWorks windows. Okay, the first step we should to start is create the center line of the shaft because we need to revolve it about the center line. Under the line we have the center line and create the horizontal center line. Here this is the 500 millimeters is the total length of the shaft. Dimension the center line at first into 500 millimeters. Imagine the center line is the total length of the shaft. Okay, I want to start the left of the shaft. Here we have the diameter 30 millimeter and the length of this diameter is 45. Use a line, horizontal and vertical line. When you select the line, after that select the center line. We have the two options. When you drag it below the center line, it shows you diameter. When you go up to the center line, it shows you the offset about the center line. I want to define a diameter and goes down. Change the amount into 30 millimeters diameter and the length is 45. Okay, after that we have the angle line that has angle about the horizontal is 10 degrees, and here the 15 millimeter is the length. Select the line, go up and create, go up and create the angular line. Make a dimension about the horizontal is 10 degrees, and here the length we have the 15 millimeters. Okay, create a horizontal line. The next diameter we have the 48. Don't have a mistake with the 44. Make a dimension diameter 48. Here the length of the 48 is here 200 millimeters about the left side of the shaft. Select this line and this point should be 200 millimeters. Okay, here we have it's like a disc. The thickness is 10 millimeter and the diameter is 60. Use a line again and create a disc like this and continue till here. Here the thickness is 10 millimeters and the diameter is 60. After that we have the 48 diameter. As a previous we have the 48. It doesn't need to use the smart dimension and make it define 48. Just make a trick and use a relation. Select this line and this line should be in the one direction, horizontal axis. Use a collinear axis. Look. When I use a smart dimension, it shows us the 48mm diameter. Okay, let's see the right side of the shaft. Here the 48 diameter, the length is here, 200mm from the right side of the shaft. Smart dimension and select this point, and the right side of the shaft is 200mm. After that we have the 45mm. The 45 is smaller than the 48. It means when you use a line, drag it to down. After that the length, here the diameter is 45. The length of the 45 is here, 140mm about the right side. Select this point, and this point should be 140. The next diameter is here, 48 diameter in 40mm offset about the right side of the shaft. Goes up and continue, for example, to here. Make a dimension diameter about the center line is 48. And the length is here. Select this point, and this end of the right side of the shaft is 40mm. The last diameter is here, it's a 30 diameter. Just connect. Okay, use a line, go down and just connect this shaft to end of our point of the center line, and make a dimension 30, and it's finished. Look. Okay, our sketch is fully defined. You can see the nodes in the coordinate toolbar, and the color turns into black. Directly go to the feature and select the revolve ball space. We have the error, and your sketch is open because we have the center line, and we have the line. But it's okay. Select the yes. It means it turns our center line into line. In the revolve ball space, we need to define two options. One of them is the axis to rotate. It's automatically use the center line. After that, we have the rotation degree. When you, for example, need to half of the shaft, just write MN 180 degrees. It creates you the half of the shaft. I can show you here. Look, our shaft slices into half. Okay. Right click, edit the feature, and change the amount 360 degrees. Okay, our shaft with the one feature revolve created. I maximize the drawing. Here we have the two keys, the right side and the left side. Right side is the slot key, the left side is the range slot key. Here we have the 2 points. To create these keys, we need to create a plane on the cylindrical face. In Solidworks, to create any feature, we need to create a sketch. When you create on the top plane and select and create this shape, it started to cut from the middle of the shaft. But I show you two options. Select the top plane, create a new sketch. Our slot to create it is here, this right slot. We have the some option, but the first is our goal. For example, create this slot, just drag it here, for example, exit and create extrude cut. Look, our sketch will extrude our shaft from the middle of the shaft, but we want to start it from the top of the diameter, or should be tangents on the top place of the cylindrical position. But we have the solution here. The first part, we have the offset. You can define which offset, for example, our sketch should be start. Here the 48 diameter, we need to create a slot key on it on the 48 diameter, but it started from the half. We need to go up the half of the 48. 48, the half of the 48 is 24. Look, our sketch created on the top or tangent about this diameter. Okay, here we have the depth number 4, depth of the slot hole, and select OK. Look, our slot is created. The second option is here, delete the cut extrude and tick the delete absorb feature. It means its sketch will delete. Okay, maximize the SolidWorks windows. Here the geometric reference, select the plane. Here we have the 3 references to create our plane, but we need just use 2 references. On this face should be tangents. After that it should be parallel about the top plane. Okay, change the parallel. Here look, our plane created about the tangent of the cylindrical face. Do it for the left side. Delete the plane number 1. The first reference is the cylindrical face and the second is should be parallel about the top plane. Okay, our planes are created. Let's select this plane and create a sketch and follow this sketch. The length of the slot key is 70 millimeters, the width is 19, and the depth of the slot is 4 millimeters. Okay, as previous operation, uses stride slots, drag it to here and drag it to Z axis. Make a dimension, the width is 19. Here the total length of the key, selected this face from the maximum. This curve is 70 millimeter. When you hold on the face, on the curve face, the yellow point, it's the midpoint of the curve will appear. Select on it and make a dimension 70 millimeters. And drag this point till here. For example, I can show you in an isometric view. I can normal to view again. Here our slot is located the half of the shaft. It should be symmetric about this diameter. Here we have the origin of our slot. Select on it and the origin of the shaft should be in the horizontal direction. Okay, it's located about the half of the shaft. Go to the feature and select the extrude cut, and the dimension or depth of the slot is 4 millimeters, should be cut. Okay, here we have another key in the left. It's the rectangular, the width is 19 and total length of the key is 70 millimeter, and it's located about the left side of the shaft is 70 millimeters. Select the plane number 2 and create a 2D sketch, and here select the center rectangular. The width of the rectangular is 19. The total length is 70 millimeters. And about the left side of this face of the shaft is 70 millimeters. Here all dimensions are inserted, but our sketch is underdefined. To fully define, select this point and the origin should be in the horizontal. Go to the feature, extrude cut, and depth of this rectangular keyhole is 4 millimeters. Okay. The last feature remains is to create this hole. The specification of the hole is we have the C countersink hole. The bigger diameter our C sink is 16. The drilling hole is 10 and 4 is depth of our hole. Select this face, normal to view. In the feature tab, select the hole wizard. Here we have some types of the hole. If you want to create a custom based on your dimension, just select the legacy hole. It doesn't base off any standard like ISO or DIN. Change the type into C sign drilled. You can see the sign of the hole here. Change the value of your hole. The drilling diameter is 10. The depth of this 10 millimeter is 4 millimeters, as C sign diameter is 16 in 82 degrees. And here the end condition is blind. The second tab, we have the position. To define the location of the hole, select this face and select or coincidence about the origin of the shaft. Okay. Isometric view. I can show you the hole in the section view. Look, our hole is created. The last feature remains. The last operation remains is to make all sharp edges into radius or fillets in radius 2. Run the fillets. Change the amount number 2 and select the all sharp edge. Okay, select both planes, right click and hide this plane. Our shaft is created. Just edit the material, right click on the material and edit the material. In Solidworks 2024 version, you can search it steel. In a search toolbar, it shows you some alloys of the steel. Just select the alloy steel, apply. The color of the shaft is changed. It means our material is inserted or applied to our body. Okay, our shaft is created. I hope you like it. If you have any question, just comment below the video. You can download it, the solid file. Also, you can download the PDF drawing in the Telegram channel. And thanks for watching.